Hello everybody, welcome to the channel, and today in this video we are going to be looking at what derivatives are and everything about derivatives. So it's going to be so cool to know about derivatives. I hope you have already seen like what differentiation is, at least how it's denoted, or if you just want to learn about calculus, derivatives, or differentiation, or just anything related to that. Then this video is for you, because we are introducing you guys to calculus a bit, and I myself am a student learning calculus, so this is going to be like a student's teaching to other students. So I'm going to be having all the problems that you guys can face listed in the channel or video itself. And now, first of all, I'm going to be starting out with what a derivative is, right? What does it mean to differentiate a function? So first of all, we need to know what a function is. So I'll give you guys like how it's written down, right? So if you want the definition of function, then you guys can just look at it yourself, but we are just starting out, calculus. We are going to be going gradually into integration, antiderivatives or anything like that. And we will be doing some complex questions in the coming future if we stay consistent. So I cannot guarantee that either of us is going to be inconsistent with the channel, but I can also guarantee that we don't know what happens. So let's begin. So what is a function? So a function is basically like a machine. F of x equals to ax plus b. So this is a function. For example, if you look at it carefully, then this f is the name of the function. So the name of the function can be anything. It can be g, it can be h, it can be even what can we use? It can be anything. You just get it like that. It can be $x, it can be %x, it can be like bracket x, though that doesn't make sense, but still I'm just giving you like an idea of what a function name is like for you guys and us when we deal with the functions and how to solve these questions. So f of x is like just the name of a function. So a function has a few parts. So we have the name of the function, which is f here, and we have these parentheses just to make sure that whatever holds inside of it is going to be the variable for the function. So that's going to be like x. So how do you get this? Well, we say, let's say a quadratic equation, a linear equation, right? So let's say ax plus b equals 0. So I can call this a linear equation because the highest degree of polynomial here is 1, because a polynomial, when we look at it, when we try to calculate its highest degree, we just look at the degrees or the powers of the variables in the polynomial. So if we assume this to be a polynomial, then what happens is we have a as a constant, b as a constant, because usually the letters taken like from the frontal sides of the alphabets are mostly constants, and the letters taken from the behind part of the alphabets are mostly variables. Like we have x, y, and z, these are all variables, and a, b, c, d, and also k. These are some examples of constants. So we have here x is a variable, and that's just x to the power 1 right here. So the highest degree of the polynomial ax plus b is 1. So degree is 1. So it's called a linear equation, right? So this is a linear equation, and if we had x. So if we had ax squared plus bx plus c equal to, let's say, 0, then here we get another degree that becomes 2, because the highest power of the variable is 2, right? So this is called the quadratic equation. So this is called a quadratic equation, and we get like, so here only x is the variable, a, b, and c are the constants, if you guys already know that. And if we have ax cube x cubed plus bx squared plus cx plus d equal to 0, and that's when we're having a degree of 3, which we call a cubic polynomial or cubic equation, right? So these are a few types of examples of types of equations, and these equations can be written as a function. So if we had y equal to the function, right, y can have any value. So if we put in x equals, for example, if we had y equal to the left hand side of all the equations, then what we could do is when we plug in 1 as x, then that would be just a plus b equal to y. When we plug in 2, that would be 2a plus b. So in order to make that simplified, what we do is we write in f of x. So f of x is equal to ax plus b. If you look at it carefully, then this ax plus b is the same as this ax plus b. So f of x is also equal to y of a function. So whatever you keep in as x, you will get as y. For example, if we had, okay, let me give you an example. So for the equation 2x plus 3 equals y, if we plugging x as 5, then what we get is 2.5 plus 3 equals y, and then that's going to be 13 equal to y, right? So you all guys get this. So next thing is, like, if we do the same, we know that y is equal to f of x, and f of x equals to 2x plus 3, right? Now, in order to plug in like x as 5, we write f of 5, because like x has been replaced by 5, and we replace that x with 5 in the entire equation. Oh, sorry, this is 2x plus 3 dot 5 plus 3, which means f of 5 is equal to 10 plus 3, which means f of 5 is just basically equal to 13 as well. So functions are an easy way of writing like equations. So if you ever see f of x, then that's equal to y, which is equal to the expression in terms of x or something like that, any variable. So this is a simple concept of functions. So why are we looking at functions? Because mostly in mathematics, whatever we talk about, it's in a lot of cases represented by functions. So we need to know about functions, because like if calculus is the process of making sentences, we have to start with the alphabets, and the alphabets start with A, which in this case we call function. Okay, so that's the basic thing. So now what do? Well, if we have this function and then everything like that, then we can go ahead and look for straight lines. So the straight line is given by an equation of y equals mx plus c, and this is, as you can see, a linear equation. So this is a linear straight line. So a straight line has, if a linear form, then that's going to be a straight line, because that's a straight line. Whatever, if it, if anything, any kind of equation in terms of any type of variable with the highest degree of polynomial equal to 1, then that's a linear equation. And its graph, when you plot it in a graph, what happens, it becomes a straight line. So that's the basic thing. So you can call it fx equals to mx plus c. Now what are the meanings of m and x? Well, m and x mean, okay, x, you know what it is, it's just a variable. So what does y equal to mx plus c mean? Like, what is m and what is c? I'm going to be showing you guys what that means in a second now, right? You guys will be shown what it means. So I'm going to be wanting to plot a function. So look at this. This looks a cool thing. It looks like a cool thing. So okay, and okay, so this is a 3D function. I want a 2D function. I want to like a simple graph for plotting in the function. So I can just remove this. I'll show you guys what it is and how it is, so you guys can like get the thing. Okay, here we have it. So fx it's equal to mx plus c, and fx is equal to y, right? Fx is equal to y. So I'll show you guys what this graph means. So this graph is the graph of real numbers, right? So we have like the graph of numbers going from left to right and right to left and top to bottom or bottom to top, whatever we call it. So the center point, so we can see that this line has two axes, if you can see that clearly. This is one axis and this is the other axis. So we have two lines basically intersecting each other at 0. So I'm going to be teaching you first how to read the graph. So if you look carefully, this is 0, right? This is 0, and then if I choose any point, if I choose the point where my cursor is right now, how is it going to be pronounced? It's going to be pronounced as 1, 1, an ordered pair of 1, 1, if you get that. So an ordered pair of 1, 1 is going to be written in a way like 1, 1. So an ordered pair is going to be enclosed within parentheses, and if it had been an ordered pair of 1, 1, then this is the point over here. And how do we say this is 1, 1? So first we look at how many units the point we're looking at is far away from the x-axis in terms of the x-axis. So if we look at it here, it's 1 unit far away because we're in this point, so this is 1 unit, so 1. And how many from the y-axis? We look here, it's just 1 unit as well, so it's 1, 1. So what if I look at this one? It's 3 units in the x and 1 unit in the y, so it's going to be 3, 1. So 3, 1. But we cannot write it as 1, 3 because it does not make sense. Look at this. 3, 1, if it's this, then 1, 3 is going to be this, and that's totally a different point from what we're looking at, so we cannot do it that way, right? So this is an important thing, and that's the basically concept of ordered pair. And now let us look at a straight line first of all. Okay, this looks pretty good in this place. So we will be looking at a straight line. I hope I can reopen the function. Okay, I can. Right, so let's look at fx equals to 2x plus 3, right? If I plot in like this, fx equals to 2x plus 3, then what happens is when x is equal to 1, then that's going to be 5. When x is equal to 2, it's going to be 7. When f is equal to 3, that's going to be 9. So it goes on. And if you look at it clearly, this has a linear progression, right? This has a linear progression. It has an arithmetic progression. As x increases by 1, the value of f of x increases by 2 from the previous value of fx. So this is how it is done. Now if I plug in the thing, so when x is equal to 1, y is 5. So when x is equal to 2, y is 7. When x is 3, y is 9. So that's the basically concept of the thing. So let me show you how the graph of this function looks like. So since it is a linear polynomial, a polynomial is anything in terms of x unless its power is positive, and it does not have any fractional powers. I think that's what we call a polynomial in a formal definition. So if I plug in this formula, if I plug in this thing, we are sure to get a linear outcome in the graph. It means we are going to be getting a straight line. So this is 2x plus 3. And now you guys can see that we have a straight line. F of x is equal to 2x plus 3. For example, if x is 1, look at this, where is x1? Here it is. So 2 times x is going to be 2 plus 1, 5. So 1 corresponds to 5 over here, if you can see that, right? So that's the basically that's the concept. And if x is 3, then 3 times 2 is 6 plus 3 is 9. So see what it meets. So it meets at 9. So this is the thing. And when x is 0, then that becomes 3, because 2 times 0 is 0 plus 3 is 3. 0 comma 3. So this is the straight line. And now how do we use this? What is the use of this graph in understanding different things? Well, there are a lot of uses. For example, this is the graph. Like, we can see how a function changes, and then we can see a lot of things as well. So in the equation y equals mx plus c, if we compare these two equations, then we get m is equal to 2 and c is equal to 3. So what is 2? Let's leave that for now. But what is 3? Well, 3 is a point where the line cuts the y-axis. So this line going from top to bottom is the what is this? It's the y-axis, and the line going from left to right is the x-axis. So whatever is above the origin for y, it's going to be positive, and whatever is below the origin, it's going to be negative. So we have the numbers written in positive and negative formats. So similarly for x-axis, whatever is to the right of the 0 or the origin, that's going to be positive in terms of x, and whatever is to the left of the origin for x, it's going to be negative. So that's a very simple concept. And if we look, we have 4 quadrants. This is the first quadrant, second, third, and fourth. So in the fourth quadrant, both x and y are going to be positive. In the second quadrant, x is negative and y is positive. In the third quadrant, x and y both are negative, and in the fourth quadrant, x is positive but y is negative. So quadrants go in anti-clockwise direction. So first, second, third, and fourth. So we go on. If somebody says you what is the fifth quadrant, then that's, you've got to do 1, 2, 3, 4, 5. So first quadrant is also the fifth quadrant. So if somebody tries to trick you up, because we are just going in anti-clockwise direction, and then the lines are intersecting each other, making right angle at any angle, right? So the sum of all these angles is going to be obviously 360. I don't need to tell you that. And this 3 is c, which is the y-intercept. So y-intercept is the point where the point in y-axis, right? It's the number or magnitude of y-axis in which the line cuts y-axis. So if it was like 2x plus 5, then this point of intersection between the line and the y-axis would be at 5. Look at this, right? It's at 5. If it was just 2x, then that would be meaning that it has no y-intercept, so it means it would be passing through the origin. Look at this, right? It's passing through the origin. So this is the simple thing. So I'm going to be showing you a few graphs. So y equals to x is this. Whenever y of x means f of x, according to whatever we have learned, and any function in terms of x is going to be giving you value equal to y. So when x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. So that goes on forever. For example, if we zoom out, and when x is 20,000, y is also 20,000. So that gives you a basically understanding of the things. And we have a lot more things to learn. And the next thing is, what is m? So if we go 2x plus 3, okay, 2x plus, let's go for x, y, no, 2x plus 3, then what it means is, well, whatever the straight line is, the rate of change of the straight line is 2, because when we compare it to y equals mx plus c, m corresponds to 2, which means m is 2, which means the slope of the line is 2. So what do we get from this? Well, from this we say slope. What is slope actually, if you want to know? Slope is defined as rise over run, if you get that. Right? It's defined as rise over run. So simply, okay, I'm going to be giving you a simple example. Y equals x. So how much have we risen? So here c is 0 and x is just x and m is 1. Now if we see rise, let's say we look at these 2 points. Okay, we look at 0, 0 and 3, 3. So how much have we risen from 0, 0 to 3, 3? Well, that's going to be the y coordinate of 3, 3 minus the y coordinate of 0, 0, which is 3 minus 0, right? Divided by rise over run. So how much have we run? The x coordinate 3, 3 minus the x coordinate of 0, 0, which is 3 minus 3. So that's 3 divided by 3, which gives us 1. So 1 is right over here. So this is the way to find out slope. And now we can also find out slope by another method. If we look at it carefully, the angle that it's making, the angle that the line is making with the x-axis in the anti-clockwise direction is 45 degrees. Right? If it's 45, then tangent to 45, tan theta, when theta is equal to 45 degrees, then tan theta is going to be 45 as well. So slope is also equal to tan theta, where theta is 45. Now tan 45 is just 1, so that's y of x equal to y. Sorry, to x. So simple thing, right? This is basically the concept of graphs. And now this is going to be like taken to a next level when we look at other sorts of graphs. Now, if we have a quadratic equation, for example, okay, we get a parabola. Look at this. What a beautiful shape it is, right? It's equidistant from both the it's equidistant. The two corresponding points it has is equidistant from the y-axis. So for one value of y, it has two values of x. So for one, it has minus 1 and 1. So it's equidistant. If we have a cubic polynomial, now it goes like a thing, whatever it is. I don't know how to pronounce it. If we have to the power 4, we again get something like a parabola, but it looks a bit different. If we have 5 as the power, then this is the same thing as the 3rd power, but as the 3rd power, but it's gotten a bit elasticated. 6, it's getting more squarey. 7, it's going to be getting bigger. 8, let's say 88 is going to be like getting like almost like a square. 100 it's almost like a square. If we add in like one more 0, this is totally a square. Look at this, right? So this is so awesome. So we can look at different graphs. So you don't have to look at the millionth power of x, you just have to look at the first and second power of x to the most case. So after we have done this, like we have this graph over here, we can calculate the slope by different ways. So for the calculation of slope is denoted by y. x2, how do I give subscript? x2 minus x1, sorry, it's y2 minus y. So y2 minus y1 over x2 minus x1. So this is the formula for slope, right? And we have another, and is also equal to tangent of tan theta, where theta is the angle the line makes with the x-axis in. So positive direction means anti-clockwise direction. So for the negative direction it means clockwise direction, right? So simple concept over here. And like these are just some basic ways of calculation of slopes. If we have like y equals to ax plus b, then we can do another way as well. We can just directly compare m equals to a, just comparing it. If we have the straight line equation given in the format of ax plus by plus c equals to 0, or something like this, then you have to rearrange the straight line to come to this form, ax plus by plus c, then then slope of the line m is equal to minus coefficient of x, which is a over b, the coefficient of y. So this is also the slope of the line. And how do we get this? Well, we can get this by we change this equation in this form. So why do we change it time and again? You can just change it yourself. You can just keep y separate, take these two things. Okay, let me do it for you guys. So by equals to minus c minus ax, y equals to minus c minus ax, so that's negative c, right, over b. So this can also be written as y equals to minus a over b x minus c over b, but this is going to be plus. That's plus times minus is minus. So if we look at this carefully and compare this to y equals mx plus c, then x is x and m is minus a over b, and c is going to be minus c over b. So simple thing, right? Then y intercept is going to be minus c over b. So this is the thing. So we have learned a few things till now, mainly functions and a bit of coordinates. We have learned what a straight line is, and all these formulas that I've given you for calculating the slope, they're just for the straight lines. They're just for linear equations. They don't work for higher degrees equations. So that's the thing. So if the slope of any line is constant, then that means the line is a linear equation. Line is linear. So for example, here if we look, there's a linear equation, so that is the reason why the line is moving in a straight path. So whatever 2 points we take as x1, y1 and x2, y2, all we are getting is just 1. So simple thing, right? I'm not going to be elaborating it even more. If you guys already know this thing or any other thing like that, then you can just skip a bit and go to the main part. And this is basically the thing. Now let us assume a thing, right? We know how to calculate the slope of this. What if we had to calculate the slope of x cubed plus 3x squared plus 5x plus 9? What if you had to calculate the slope of this? Look at this. This doesn't even appear to be a straight line, does it? This doesn't even appear to be a straight line, and if we look, the line is changing continuously. So the slope is something over here, it bends, which means the slope is something else over here, it bends again, which means the slope is something else, again it goes on bending, so slope goes on changing. So we don't have a fixed formula to calculate the slope of the straight lines with degrees higher than 1, right? So we have to use different methods and approaches. So the slope is variable. The slope is constant only for the linear equations, which is a very easy thing to calculate, but for higher degrees equations like quadratic or cubic equations, it's a bit difficult to calculate the slope. So for that, we are going to be looking at how we can calculate the slopes. So what is a slope? Basically, a slope is just a normal thing. The rate of change of line. So how much a line changes. Before that, I'm going to be giving you a few equations of straight lines so that you guys won't be confused. So y equals mx plus c. So another is over a, sorry, plus y over b, what is happening is equal to 1, and x cos cos theta minus y sine theta is perpendicular distance. So these are just, I'm just giving these just for you to know. You can research on these two formulas yourself, and that wouldn't be a big deal for you guys, because I've already told you the main thing, which is this formula, the slope-intercept form, right? And then this is the double slope form, and this is the trigonometric form. So you just look at it yourself. And for now, we need to look at how the slope of the line changes. So for the calculation of slope, if we look carefully, we need to draw a tangent. How do I draw a tangent here? That's another problem now. If I can't, I'll just give you a formula directly, guys. I can do nothing for that. I didn't get that. How do I add a tangent? Oh, I can. So in terms of y, implicit vectors, regular plot. Okay. I'm going to be plotting a regular line, right? And let's not even use a tangent. We will use a secant line, and I'll try to guess on my own what the tangent is going to be. Plus 2x. 2x plus 15. 2x plus 12. 2x plus 9, 8, 7, 6. Okay, 2x plus 6. You have it over here. But I want the line to be a bit rotated. So what I can do for this case is I have to choose any 2 points through which I want the line to be passing. In this case, I want it to be passing through 2 points in the equation in the cubic graph. So let's choose the 2 points to be 9, 0 and 6, minus 1. Right? 9, 0 and 6, minus 1. So the straight line, which is going to be used as a secant, is going to be having the y-intercept of 9, because that's where it cuts the the equation where the highest power of x is 3. Now we have already gotten it here to one point. Now we need it to cross through different points. Now plus how many times x? Now slope, we use the same formula, y2 minus y1 over x2 minus x1. So 9 minus 6 is going to be 3, right? Divided by minus 1, so minus 3x. So 9 minus 3x minus 3x. So what is the problem here now? Let me see again. 9 minus 6. So 9 minus 6 would give us 3. That's pretty fine. And 9 comma 0 minus 1. Oh, sorry, that's a plus 3. Okay. So we have it like this, as you can see. Now this graph is cutting the tangent is cutting the graph into 2 pieces. It's cutting it in 2 places. So now, how do we calculate the slope? Like in normal ways, we would calculate the slope of any line by taking any 2 points through which it passed, and then you just calculating x2 minus x1, y2 minus y1. That would give the same result. But in this case, it does not. Right? It does not go. So here, what we do is, if the secant line is brought closer to the blue line. If the green line is brought closer to the blue line, I'm just making it simple. If the green line is brought closer to the blue line, then what happens? Well, we get these 2 points, the 2 points of intersection coming closer, right? They come very close, which means the distance between the blue line and the green line is going to be approaching towards 0, right? It's going to be approaching towards 0. So we have one thing in our mind, that we need to bring these two things closer enough so that we can precisely calculate the slope in very close regards, and that slope is not going to be the same for the entire graph. But if we do that, what happens is the distance between the green and the blue lines, these two distances go becoming smaller, right? The distance between these 2 points smalls out. It goes going down. So it's the limit as the distance approaches to 0. Why the distance approaches to 0? Well, it's because the 2 points, when come closer, the distance approaches to 0. So for distance, if we denote it as h, okay, we're denoting the distance as h. So let me write it. Slope is equal to limit as h approaches. Do we have a plain and clear and good arrow? Why don't we have like the main arrow? Maybe approaches. Okay, right arrow. So as h approaches to 0, right? Limit as h approaches to 0 of a function. So we are having a limit of a certain function, right? We are looking at the limit of a function, and what is that function going to be? Let's look at the graph again. So as the distance approaches to 0 of the function, which is what, right? So what are we looking at? Slope. So if we want to calculate the slope, then we are looking as the distance between the 2 points that we're looking to calculate the slope is getting 0, then the function is always, it's not, let's not even call it a function, whatever we are looking with regards to is also going to be the same formula for slope. So the limit as it approaches to 0 of y2, how do I use that, minus y1 divided by x2 minus x1, right? y2 minus y1 over x2 minus x1. So what is y2 over here? This is y2. Or if we can look at the thing from different perspectives. We can look at it from different ways. Okay, let's say, okay, I did I think a small mistake. The distance h is the distance between these 2 points, right? It's the distance between these 2 points. Yeah, oh yeah, I said that. Yeah, okay, fine. The distance between these 2 points, because the smaller distance also goes down. So h is the distance between the 2 points of intersection. So when that goes nearer, what happens is, looking at the thing, y2 and y1 and x2 and x1, and what is y2? Well, y2 is the point over here at 6, and y1 is 3, right? But, right? We have a but. y2, if it's 6, and x2, if it's 3, then the distance over here is just 3. That's 6 minus 3. But in the normal cases, this is not always the graph that we get, right? This is not the graph that we get. This is just for a specific case. So we have to generalize the formula. The formula has to be generalized. So what do we do to generalize it. So y2 is 6, and I already told you guys that y is equal to f of x. So if we call this f of x, then what is y? Well, f of x is 3, then f of x plus h, which is the distance, right? If it's 3, then that's going to be f of x plus h. That's going to be y. Simple thing, right? So, and that's going to be the limit. In place of y, we put in place of y2, we put in f of x plus h minus, what is y1? y1 is y, so that's f of x. f of x divided by, now look at x's. Look at the x's. So x is, if this is called the x1, then what is this? What do you think is this? Well, that's x plus h, right? It has a distance. So this is x, and this is x plus h. So that's going to be x plus h, x plus h minus x. So if we subtract x, and we get h. So slope is defined as limit as h approaches to 0 of f of x plus h minus f of x divided by h. So if that makes sense. So we do it in that way. So that's the thing here, as it is like that, and you know, basically we do it this way, and now we can calculate the slope. Okay, let me prove to you guys that this formula works. If we have, for example, and one more thing, this limit that we have gotten is what we know as derivative. So this is derivative. So if we have a function, let's say f of x, if we have this, then what is the derivative of a function? This is the slope of a function. So derivative of a function is the slope of the function, if you get that. So it's going to be represented by, slope of a function is represented by f prime at x. So this little dash thing here is called f prime at x, which represents the derivative of the function. So it's important, and that's how we calculate the derivative. So if we have a function f(x), then that's going to be having a derivative of f prime at x equal to limit at h approaches to 0 of f of x plus h minus f of x divided by h. Now if we have a function, let's say f of x is equal to 2x plus 3, then just using normal ways, f of x equals to mx plus c, then that's m equal to 2, right? M is equal to 2. Now let's use this formula for calculating the same slope, if we get that. So for calculating the same slope, we use limit as h approaches, now how do I write? Approaches to 0 of f of x plus h. So in place of x in the function of f of x, we have to input f of x plus h. So 2 times x plus h plus 3, plus 3 minus times 2x plus 3, so that's just f of x, divided by h. Now we don't know what the value of h is. For now, let's keep it at just h, right? So that's going to be equal to limit as h approaches 0 of, when we open this thing up, this becomes 2x plus 2h plus 3 minus 2x minus 3 divided by h, right? So that's going to be equal to limit as h approaches to 0 of. Now the 2x and minus 2x get cancelled, and 3 and minus 3 also get cancelled. So what remains is basically 2h over h, and since we haven't kept the value of h, and since it's not equal to 0 but just approaching to 0, we can cancel out the h's. So limit, that's going to be equal to limit as h h approaches to 0 of just 2, which is just 2, because now we don't have anything called x in there, so this is limit, which is f prime of x, which is the slope of the line, right? This is 2, so the derivative of the function is 2, and the slope of the function using normal methods is also 2. So this means we have successfully calculated the limit of a straight line using the not limit, but the derivative of straight line using the first principle. So this is also called the limit definition of derivatives, or it's also called the first principle of derivatives. So and the process of derivating a function is called differentiation. So we were basically differentiating the function 2x plus 3 equal to f of x. So when we differentiate it, we get the derivative, that's 2, and that's the basic thing, right? And now, using the limit thing. Why do we use this? Well, isn't this easier to use just like these formulas? What do you think, guys? Well, it is easy to use these formulas, but what happens is there's a problem now. That is, we can use these formulas for only linear equations, but we can use this formula for every sort of equation. So that's the main important thing. For example, if you guys want to calculate the limit of the function given in the graph, we can calculate that as well, but I'm not sure about how long it takes to do that. So slope is equal to 2. So what do? Well, we could like type in, this is the y, which is f of x. So this is f of x. So now f of x is equal to x cubed plus 3x squared plus 5x plus 9, right? So now how do we calculate the derivative or the slope of f of x? Well, that's an important thing. Now, in order to do that, we write the same limit definition of derivatives. What did I do? Okay. We write the limit definition of derivatives, f prime at x, and we say, let me just copy this, because this is going to be used a lot. So, or let's do a thing, let me copy this entire part, right? So, why am I cutting this thing? I have to copy. Okay. So this is equal to now f of x plus h. So x plus h whole cubed, x plus h raised to the power 3 plus 3x plus h squared, x plus h squared plus 5 times x plus h, right, plus 9 minus, now we get a minus x, okay, we just simply can write this thing, minus 9, so minus this, and these pluses are going to be replaced by minuses when we use the bracket to be opened by minus. So this is what we get, right? And now we can simply say that this thing is equal to x plus h whole cube. Now this is going to be getting a bit lengthy, you know, it's going to be getting a bit long, but we can solve this, that's for sure. Okay, let me do it for you guys. So let's keep x plus h whole cube for the last, because that's going to be making the work very dirty. So yeah, so that's going to be making the thing a bit shorter and cleaner, divided by h, and plus, now I'm just directly going to be doing that, 3x squared, 3x squared, what is happening guys, 3x squared plus, now 326, right, so 6hx plus h squared, and then plus 5x plus 5h plus 9, and copy all these things. So a few things will get cancelled now, but not all of the things. So frac. So just copy some parts of it. So yeah, if you do it this way, when you just keep on doing, and you will eventually end up with some value, right? So I think it's going to be very long to do. So let's keep it to be continued. So we will be doing this, or we might not be doing this, because if we now expand this one, it's going to be getting very long, and we have to think a lot for how to solve this. So this is going to be so long, you know, differentiating this function with the limit definition, so that it'll take a lot of time. So we just want to do this. Now, you might be saying like, if we have this formula to calculate the derivative, and this formula is going to be making things super long, what's the point of using this formula? How do we calculate the derivative? Now, I'll tell you something very important. Now, this is just a definition of derivatives, right? So, like, you don't use this every time when you have to calculate derivatives, because like it's going to be super long and it takes a lot of time, and you could like do like, you can differentiate like 20 functions till the time you differentiate one function using this formula sometimes. So this is very important. Okay, so how do we calculate the derivative now? So in order to calculate the derivative, we have a lot of formulas, right? And we have a different way of writing the derivative notation. So for example, let's say for f of x, we write it as f prime at x, right? For f of x, we write it as x f prime at x, and that's so cool, right? Now, next thing is, since we know that f of x is equal to I, we can say that frac dy over dx is equal to f prime at x. Why is it? Because like we are differentiating the function y with respect to x. What does it mean? It doesn't mean anything. All it means is we are differentiating the function y, which is f of x, with respect to x, which is the variable, like in all the cases we have. So the function y is going to be having x as the variable, and that's the thing. So we have it in this way. So f prime at x is equal to dy over dx, and we cannot cancel these d's, right? The d in the denominator and the d in the numerator, because like this is like just a symbol or a notation used to define derivatives, that we are differentiating a function y with respect to x, which means that we are differentiating a function where x is the variable and the function is y. Simple thing. Like sine, okay, let's say okay, sine of theta, right? Sine of theta divided by cosine of theta. If we divide that and then we say sine and sine are the same, which means theta is also the same, and we just cancel those things out and we have 1 over co, 1 over co. That doesn't make sense, right? In the same way, we cannot cancel these two d's, so that doesn't make sense either. So this is a way of differentiating a function. Now I'll show you like something very importantly else. Now we have a lot of rules and formulas for differentiating a function. For now, we will be looking at the formulas. Formulas for differentiation, and we haven't written much since the starting of video, and it's already been like an hour. Just because we have like grasped a lot of concept, right? We have grasped a lot of concept, and we have also looked at the graph and understood what it is, what the graph means. So this is like an absolutely epic achievement. So you guys should be continuing this if you want. And now, so formulas for differentiation. So dy, let's say d over dx, d over dx of c is, what is it? 0. So the derivative of a function that gives a constant output is 0. So y is equal to c here. So if y equals to c, then f of x equals to c. And whenever we put in x, the function is going to be having the same value. It means there is no change. The line is just going to be in parallel with the x-axis, so there is no slope. It's just straightly parallel with the x, so it's 0. So this is like how we differentiate a function. And now we have d over dx of variable x, and that's going to be just 1. If we have the d over dx of ax, then that's going to be a times d over dx of x, which is going to be just a, right? So it means that while differentiating a function, if there is any constant that's multiplying with the variable, then we can take the constant out of the derivative and then differentiate the function with respect to that variable, and then when we get the output, we multiply it just by the constant. And here it's a because it is a times 1, which is the derivative of x. Now next is the power rule, so we can like call these some rules. Constant rule, and I'm just giving names to these rules. People would not like me giving the names to these rules, but for making it easy, like, you know, it makes a bit more organization here. It makes it organized, so I'm using the names. The x rule. Okay, this name does not exist, but I'm creating it myself. And now this is going to be the constant variable rule, right? And then now comes the power rule. So these are some rules. So we have the power rule now. So the power rule states that the derivative of x raised to the nth power is equal to n times x raised to the power n minus 1, right? So this is important. So the power rule states that x to the nth power is equal to, the derivative of x to the nth power is equal to n times x raised to the power n minus 1. This is the power rule. We give some spaces. And now we have constant power rule. I'm making this name myself. Frac d over dx. So if we have a times x raised to the, where the hell is 5 or 6 n, then that's going to be a times the derivative of x to the nth power, and that's going to be a times n times x raised to the power n minus 1. So this is also important. So this is how we differentiate a function. I hope you get that. So this is also absolutely important. And we have like a lot more things here. For example, if we have another rule, that's the sum rule. So this is the actual name for the rule. So the derivative of any function that's f of x is y plus g of x, that's equal to the derivative of f of x plus the derivative of g of x. So it can be either plus or minus. So here plus or minus, so depending on the sign. So if it's to be written in this way. So like this. So it's going to be this thing, and now we have product rule. Let's see, the product rule says derivative of, let's go within a bracket, f of x times c of x is equal to the derivative of f of x. What happens? F of x. So this is the derivative of f of x times g of x plus the derivative of g of x times f of x. So this is the product rule, and we can also write it as f prime at x plus, f prime at x times gx plus g prime at x dot fx. So this is another way of writing the product rule. So these are any two functions, right? And if we have, now we have the quotient rule. So this rule is used for dividing. So if we have the derivative of f of x over the derivative of g of x, then that's going to be the derivative of, like, it's going to be in a fraction. So fraction in a fraction. So that's going to be the derivative of, it's going to be the derivative of f of x, and that's going to be kept in a bracket. Right. So the derivative of f of x dot g of x minus the derivative of g of x dot f of x over g of x's square, right? This is another formula. You can simplify this thing as 1 over g of x square times this, right? And you have also another way of writing this, which is equal to simply copy this, right? And in place of 1 we write f prime at x gx minus g prime at x f x. Simple, right? So this is all equal to the quotient rule. And if we have something like the Euler's constant rule, the derivative of Euler's constant e to the power x is just not going to be changed. It's remaining e to the power x. Simply, right? This is the Euler's constants rule, and the logarithmic rule. So this is the derivative of, we can like have a lot of things. So natural log of x is equal to, so the derivative of natural log of x is equal to 1 over x, simply. So the derivative of the derivative of natural log of x is equal to 1 over x, and there are many more formulas like we have now. Okay, I'll show you something cool. You just open up a tab in your in your browser, and then what you do is you type in differentiation formulas, and you get all the rules here. See this? You can do this as well if you like forget the formula sometimes. Then you can do this. So which is it's going to be just very helpful for you guys. And I had forgotten to mention one formula which I got reminded, which is the chain rule, but I'm not mentioning it right now because I'll mention it later on. So the logarithmic rule now, the derivatives of trigonometric functions. Rect d over dx of, I think I can copy this part. Like, why do I have to write it all the time? So derivative of sine is cosine. So, and the derivative of cos x is minus sin x. And the derivative of tan x is equal to sec square x. And the derivative of sec x is equal to sec x dot tan x. And the derivative of cot x is equal to minus cosec square x. And the derivative of cosec x is equal to minus cosec x dot cot x. So we have the derivatives of all the trigonometric ratios, right? So this is also very important. And now we are going to be maybe doing a few problems related to derivatives so that we can increase the understanding of derivatives. So some problems related to derivatives. So we have like written a lot of formulas down along with the graph visualization. So this is so cool and awesome. So yeah. So we are looking now at some problems related to derivatives, and I have a book which has a bunch of derivative problems. So I'm going to be taking the book out, and I'm going to be doing some problems from there, from the book itself. Right, so I have the book out now, and now we will be going from easy questions to a bit harder, and the hardest questions probably. So the chain rule, I have not told you the chain rule yet, but that is for not for now. So I hope like this video is made keeping in mind that you guys probably know about limits. If you guys know about limits, then you guys can continue. I mean, if you don't know about limits, then still you can continue, but just if you want to get an intuitive understanding of the f prime at x, then you have to know about limits. And I think most of you already know, because you're coming here to watch the videos for calculus, derivatives, antiderivatives, then you probably know about limits. And if you don't know, then still you're getting to know how to calculate the derivatives, because like here's nothing related to limit. Sometimes we might need it. So some problems related to derivatives, and let me look for some problems related to derivatives. Okay, now I have turned to the chapter with derivatives questions. Okay, we have a few questions. So now we are going to be finding out the derivatives of a few functions. Okay, so let's see. We have a lot of functions of which we can find the derivatives, and let's find the derivative of like we could also practice the question using the first principle, but I won't waste the time there. So okay, let me copy this so to make the things faster. Okay, now we have to calculate the derivative of x cubed plus 7x squared, 7x square, x cubed plus 7x squared plus 2x plus 5 plus 2x plus 5. So in order to calculate the derivative, we have to use the sum rule. So this is going to be equal to the derivative of x cubed plus the derivative of plus 7 times the derivative of x squared, x square plus 2 times the derivative of x plus 5 times the derivative of 1, right? So we have taken the constants out of the derivative, and we are just differentiating the variables. Now use the power rule. So x raised to the power n, when differentiated, we get n, which is 3, times n raised to the power x raised to the power n minus 1. So that's x raised to the power 3 minus 1, that's 2. Now plus, we get a 7 times, same, 2, because that's n, times x raised to the power n minus 1, which is just x to the power 1, plus 2 times the derivative of x is 1, plus 5 times the derivative of 1, which is a constant, 0. So that's going to be giving us 3x squared plus 14x plus 2. So this is the derivative of the function. X cubed plus 7x squared plus 2x plus 5. So 1. We completed the question number 1. And then 2. Now we will be looking at the derivative of like a bit more complex functions. So x to the power is going to be 3 over 2. Sorry, 3 over 2. So we have x to the power 3 over 2 minus 1 over square root of x. So x to the power 3 over 2 minus 1 over square root of x plus 9. So how do we do this? Well, simply we can just use the power rule. So I'm not writing it in a long format. I'm just writing it like frac 3 over 2, and then this is going to be x raised to the power 3 over 2 minus 1. That's going to be simply 1 over 2. So x to the power 1 over 2 is simply the square root of x. Right, simply the square root of x. And minus, this is the derivative of x to the power negative 1 over 2. Fraction minus 1 over 2, because like this is 1 over 2, and when it's brought up it's minus 1 over 2 plus 0, because the derivative of 9 is 0, and we add things. 3 square root of x, oh sorry, 3, right? 3 times the square root of x over 2 minus times minus plus 1 over 2. So 1 over 2 times x raised to the power of still 1 over 2, so root x. Root x. So because like 1 over 2 plus 1 is just 1 over 2 plus 0. So we can take 1 over 2 as a common factor, sorry, root x as common factor. So this is going to be square root of x, and we can write it in this way, outside of the root. This is going to be 3 over 2 plus 1 over 2 is going to be equal to square root of x times 3 plus 1 over 2, which is 4 over 2, which is, okay, 4 over 2, that's 2 square root of x. So this is the derivative of the function, right? This is a simple way to differentiate the function, and we can use different ways in order to differentiate the same function. So this is a cool thing. And now, like, you know, this is absolutely important. This is absolutely important. Now let me think of which question we can do. Now you guys think about everything that you have done for a minute. Okay, I think you have thought about it. And I'm ready to do or give another question, which is simply the derivative of what? It's going to be the derivative of ax plus b over x. Ax plus b over x, right? So how do we do this? Well, this is going to be the derivative of ax plus b over x, which is going to be the derivative of ax over x plus b over x. Now ax over x is just a, and the derivative of a, which is a constant, is 0, plus the derivative of b over x. So that's going to be b times the derivative of 1 over x, right? 1 over x. Now I think there is a bit of problem here, because we cannot differentiate a function in this way. Is the question something else? it says to find the derivative of that. Now, okay, we can do this. Okay, this is going to be b times the derivative of x raised to the power minus 1, right? Minus 1 times x raised to the power minus 1 minus 1, which is minus 2, if you get that. So this is going to be b and then a minus 1 and minus 1 over x squared. Simply, this is the output. So this is going to be b minus 1 over x squared. Oh, sorry, it's not b minus 1 over x squared. It's simply minus b over x squared, because like these are in product, right? These are in product, so this is like the output of the thing, and this is how we can solve the question. So the output is minus b over x squared, and now we have another questions. So let's go for a bit difficult question. Question number 4. So we have the derivative of how long is the video? Okay, it's already 1 hour 35 minutes, so it's going so long. So we have to calculate the derivative of what? Okay, let me choose a bit difficult question. Okay, let's do this one. Calculate the derivative of x squared plus the derivative of the derivative of x squared plus 5 whole squared, right? This is what we have to calculate the derivative of, and this is going to be equal to the derivative of x squared, which is 2x. Oh, sorry, we have a square bar set, right? Now what do we do? If you guys think this way, because we cannot differentiate these two separately. We cannot differentiate first x squared and then x to the 5th power, because if we look carefully, we have a square sign outside of these expressions, right? We have a square sign. So if we want to differentiate this, we have to first use the formula of a plus b whole squared. So we have to be doing that, right? So what is that? X squared, which is x to the 4th power, plus 10x squared plus 25. So let me write down the formula for you guys. The formula for a plus b whole square is equal to a squared plus 2ab plus b squared. So this is the formula. And now we can differentiate that. It's going to be 4x cubed, right, plus 10 times 2, 20x, right, plus 0. So that's going to be basically 4x cubed plus 20x, because we can just eradicate 0. And you can still take a thing in common. Say 4x cubed plus 5. So both of these can be the answers because they have the same value numerically. And now I'm going to be showing you something very awesome. Remember this graph we had done a bit earlier? We have this function and we tried to differentiate the function using the limit definition of the derivative, and we could not differentiate the function because it was getting too long and we could not find out what the slope of the function is. Now that we have the tools for differentiating any sort of function, most of the functions, so that like we have a lot of formulas, we have a lot of things. Look at these things. We have a lot of things. We have constant rule, constant variable rule, the power rule, power rule, constant power rule, the sum rule, product rule, quotient rule, Euler's constant rule, logarithmic rule, the derivatives of trigonometric functions, and we have yet to learn the chain rule. So we have a lot of rules and things to learn. So now we can differentiate this function, and I think you already know how we can differentiate the function. So let's keep it as a quest, right? So let's keep it differentiate. So it's going to be f prime. Okay, you guys can pause the video right here, and when you finally get your answer out, then you can resume the video to see if our answers, are equal. And I can be wrong too. Sometimes anyone can be wrong, so this is not a big deal. But f prime at x, it's not so likely for me to be wrong here. So the derivative of x, f prime at x means the derivative of x, which means d over dx, and the function y is equal to basically this thing, right? This thing, and that's going to be 3x squared plus 6x plus 5, right? So this is the derivative of the function f prime x. So this right here is the derivative of our function, which means this is the slope of the function, right? For example, if we have this function, right? We have this function, and we want to know what the value of y is. What is the value of y when x is, let's say, let's look at the graph first. So when x is, okay, I want to look at a good number. I need to look at a good point here, like an exact point that I can get the value of. Okay, here. When x is minus 2.5, yeah, when x is minus 2.5, what is the value of y? It should be 9, right? Let's see. When x is minus 2.5, then f of minus 2.5 is going to be cube of minus 2.5 plus 3 times minus 2.5 square plus 5 times minus 2.5 plus 9. Now I don't want to do it on my own. I'm just putting it to ChatGPT, which will do this. So the output is minus 3.75. Has it written the thing properly? And have we gotten the graph correct? Let's see. Okay, let's do a thing. Let me just give it the function. That's like I could have made the mistake, right? I could have made the mistake. Write this function for me. Let's see how it gets this function as. Okay, this is pretty fine. And now, if we plug in the value of x, we get out the value of y. So to get 9 as, I was looking at something else. Okay. So to get y as 9, what do we have to get x as? Well, we have to get x as 0, but that would be a bit too simple. So to get y as 12, okay, if we want y as 12, then we should have our x as 1. So plug in x as 1. Let's see. If we plug in x as 1, we should get y as 12. Oh, sorry, 18. Let's see what the problem is. 12 is here. It should not be like, I plugged it as 1, right? Let's see. And for 1 we get a 12. Oh, sorry. This is not for the blue line. I was looking at the green line, okay? So if I have it 1, then that's going to be 18. If you see that, 1 is going to be 1 at x, is going to be 18 at y, and that's what we get. So this means when we plug in the value of x, we get out the value of y. So similarly, when we plug in the value of what's that? Let's use 1, and that's 18. So when we want to know the slope, whether the line at x equals to 1, we do f prime at 1 equals 2, and let's give ChatGPT. I mean, I can do it myself. That would be 14, right? But let's give it. So this is 14. So the slope of the line when x is 1 is 14. Let's see. So when x is 1, at this very point, the line is changing with a slope of 14. That's the thing, right? Now the next time any line changes, the slope would be 14. That's the thing. So with this we can get the rate of change of different things, which is very important in mathematics, even in reality, in physics, and I've heard that it's also used in economics. I don't know if that's true, but I think it is. So it is very important, and we have successfully differentiated a few functions. And now let's go for a bit difficult question, right? So we were at 4, let's go for 5. So at 5, let's see what we will differentiate. Okay. Let's differentiate a function. The derivative of a plus x raised to the power 3 over 4. 3 over 4 should be in power form. 3 over, what did I do? Drag 3 over 4. Right, a plus x raised to the power 3 over 4. Is it? Yeah, so it's going to be a plus x raised to the power 3 over 4 and a minus x raised to the power minus x raised to the power 1 over 4. 1 over 4. So now, how do we differentiate this function? Well, it's pretty easy. We can say this is the derivative of a squared, right, minus ax raised to the power 1 over 4 plus ax raised to the power 3 over 4 minus x raised to the power 3 over 4. What happened? Oh crap. 3 over 4 dot x raised to the power 1 over 4, right? So this is the derivative. And now the derivative of a squared, it's not going to be 2a because a is a constant. So a squared, if it's a constant, then let's say if a is a constant, then let's say a squared is b. So the derivative of b, which is a constant, is 0. Minus a times the derivative of 1 over 4, I mean minus a times the derivative of x raised to the power 1 over 4, that's going to be 1 over 4 times x raised to the power 1 over 4 minus 1, right? 1 over 4 minus 1 is going giving us minus 3 over 4 minus 3 over 4 So plus a times 3 over 4, right? I hope you get how this is coming. A plus 3 over 4 times x raised to the power minus 1 over 4. Because like 3 over 4 minus 1 is minus 1 over 4. Minus the derivative of x to the power 5 over 4, because when the bases are the same, the powers get added, and 4 is the common factor LCM, then we get to add 3 and 2. That's going to be x to the power 5 over 4, which is going to be the frac of 5 over 4 times x raised to the power 5 over 4 minus 1, which is going to be 1 over 4, right? To the power 1 over 4. Simply, this is going to be the value. And now we can leave the answer as it is. So this is the solution to the question. And you can take 1 over 4 common from like almost all the questions, because it is common in there. And since you have x's and a's as well, you can take in those things common as well. But that wouldn't make any difference, so we can leave it in this way as well. This is like the basic way of differentiating, and you have to practice it in copy, in notebook, so that you become like an expert in differentiation, which would make you like feel more confident. And I wouldn't be making these videos if I hadn't found this website called MathCHA. I didn't know how to pronounce it. So this website is so awesome. It allows us to like write down different equations, different sorts of formulas, different sorts of notations, different things, like in a very easy way. It also allows us to create graphs, plot the values, look at how the graph changes with changing the coordinates. This is so cool website, and this is free of cost. If you want the application version of this, the desktop app, which has a lot more features but isn't as good as isn't as good as like, you know, the other probably paid apps. I don't know, but still you can use that. But for now I'm using this, and we have this as the derivative. And what is the slope of the line at x equals 1? So the slope of the line at x equals 1 is 14. So we can now go for different questions. Find the differential coefficients of the following. I can differentiate a lot of questions there. So which one is it going to be? Okay. So let's do a different type of question. That says differentiate the function, and the function is x cubed y to the 6th power, x cubed y to the 6th power is equal to x plus y whole to the power 9. So how do we differentiate this function? Now, what it means to differentiate is, it means to find dy over dx. So we need dy over dx, which is what we want to find, right? So how do we find the value of dy over dx now? So let's see. In order to calculate the value of dy over dx, we can like use a lot of ways and different methods. One of which can be to use a cube root on both the sides. So if I use a cube root on both the sides, so cube root on both the sides, x cube root of x cube y 6 equals to the cube root of x plus y raised to the 9th power, right? And this becomes xy squared equals to x plus y whole cube, if you can see this. Okay, it becomes something like this. Now from here, we need to take it into a simpler form. But if you guys look at it very carefully, this would be very long to do. This would take a lot of time. So I just wanted to let you know that it would take a lot of time, so I did this. But in reality, we don't use these sorts of ways when we have the other powerful methods. So the powerful method, we need to differentiate this, right? The weaker method. So we need to differentiate this, so we say differentiating both sides with respect to x. So what are we doing? We are differentiating both the sides with respect to x. So this is d over dx of x. I can just copy paste it. Cube plus y to the 6th power, which is equal to d over dx of x plus y to the 9th power, right? So this is the derivative. Now, how do we get out? I mean, not get out, but how do we get the derivative now? So if you look at it very carefully, what you see is you have two different things here. You have two different variables. One is x, and the other variable is y. So we need a way with which we can differentiate the values. Not values, but we need a way with which we can differentiate the variables. So what do? Well, if you look at it very carefully, what you can see is that it becomes like, if we are differentiating the function, if we're differentiating any function with respect to x, then x is a variable, of course, but y as well. It is a variable because y depends upon x, right? Since y depends upon x, y is also going to be regarded as a variable. So I hope you get that, because like if I change x, and y is also changing, so I cannot use the constant variable rule for this. I think that's what it's called. I mean, that's what it's named, I think. The constant variable rule. Yeah, here it is. So we have to use some other approach in order to differentiate this function. Now, what do you think can the approach be? Like, if you want to know, then we can probably differentiate this function by using another way. So that way would be like, firstly we want dy over dx, so we want to remove the extra things that are out there, right? So how do we do that? Well, we can do that by do it from here. Frac d over dx of x cubed plus y to the 6th power. So it's going to be the same here. Well, what did I do? Derivative of x cubed plus y to the 6th power. Now, we need to differentiate the function with respect to the same variables. Right? We need to differentiate the function with respect to same variables if we want to get the differentiation or the derivative of the function. So it's like, we have two variables. So in order to differentiate these two variables, we will have to use just two ways in order to differentiate, like dx, and how do I get this? Well, I think we can use another one. For example, if we have x cubed as y to the sixth power, then we can have like y to the sixth power represented in terms of x as well. But still, if we do that, what it does is like it makes the thing a bit more problematic, and the situation gets a bit worse. So let me look for a simpler way with which you guys can do the differentiation, right? So I'm looking here, I have written down the derivative of this, but I'm not finding it. Okay, so in case you guys don't know how to do this, like for this case, like I'm just stuck here, right? And how do we differentiate? Well, we can differentiate the function with the help of an AI, right? Because we cannot decide to say we don't know. Differentiate the function. We'll implement this differentiation. So it's using the product rule, right? And it's now using some other rules. So yeah, we can do this, right? I know how to do this, but it didn't come to my mind. So that's the thing. You also know how to do this, but it doesn't click you at some time. So how do we do this? Well, we say this is equal to d over dx of this function. But if we look at it very carefully, we get this equal to the derivative of this, right? If we look at it very carefully, and this is going to be like it's in product, right? And like this is like weird using the product rule now. So it will be the derivative of x cubed, that would be 3x squared, and then y to the sixth power plus the derivative of y to the sixth power. So drag d over dx of y to the sixth power times x cubed, right? So why am I writing this? Like, I could have directly done this, but I'll show you later on. I'll show you later on why it's being written like this. And for this, we can directly use the power rule, but for power rule, we should have the base equal, like x plus y here should be equal to this x over here. That is what the power rule says. So if we look at the power rule, x to the nth power is equal to n times x raised to the power n minus 1 only when x and x are equal. So what do? Well, we have x plus y to the ninth power, but we don't have over here x plus y. So we do frac d over d of x plus y, and now we can differentiate x plus y to the ninth power. Right? But now, since we have changed the thing, like d of, we need to add the same thing here, so we can balance the thing. We need to balance the expression. I hope you get that. Like if we have multiplied something in the denominator, we have to multiply the same thing in the numerator, and this dx was already there, so this is the thing. And now we can start differentiating the function, right? We can start differentiating the function. So this is going to be okay, let me tell you. So this is y to the sixth power, right? So we need to have a dy over here. Like I wanted to do it in the next step, but I feel like to do it right now. And now this is going to be dy to the that's y to the sixth power over there, right? So dy over dx. So we have this over here. So now we can continue, and we can say, or 3x squared y 6th power plus x cubed times 6y to the 5th power. So 6x cubed y to the 5th power dot dy over dx equals to 9x plus y to the 8th power dot, now we have like this, so dx over dx is just 1, right, plus dy over dx, if you see this, right? This is dy over dx. And now we'll have to write like this. We have to just copy this and say that this is equal to, now break this, you need to multiply the things. So this is just going to be the same thing over here. Okay, you can listen to me? Yeah. So, I've been called downstairs, so I'm back right now. Okay, so where were we? So 3x squared y 6, okay, this is equal to this, and then we have to paste it. I haven't copied it yet. So copy this, and then plus this times dy over dx. Okay? I think you get this. This is simple. And now, what do we do? If you think, what do we need? Well, we need to differentiate the function, and we need dy over dx. So if we need dy over dx, then we need to look at this. We have the dy over dx on two sides over here. So if we have the dy over dx on the two sides, then we need to bring them to the same side. So 6, okay, I'm going to be bringing this to the left hand side and taking everything else to the other side. So this minus this equals to this minus this, right? And now if we take in dy over dx as a common factor, dy over dx, then we are left with, let's see what we are left with. That's not even a fraction. So it's this and then minus this, right? And this is equal to this. So now we can look that dy over dx is equal to something. And now if I take in 3 as the common factor, and if I take it out here, 3, right, then that's going to be 2, and that's going to be changed to 3. And if I do the same here for this one as well, and that's going to be equals 9, right? So it's going to be changed to 3 over here. 3 times 3 is 9. 3 times 1 is 9. Oh, sorry, 3 times 1 is 3. So now I get to cancel these 3's, and we say, or frac dy over dx is equal to frac this over frac this. So this is what dy over dx is equal to, and this is what we have obtained as the answer to the question. Let me see if I'm correct. 5. So I'm reading this question from like a book, and it says that dy over dx is y over x. So is there any chance that we can make this equal to y over x? That's what we can look now. I can give it to ChatGPT, or at least let's see what it has taken out as the answer. I can like give it to it. Where is the question? Control C. Is this fine? You're very close. The overall structure and structure, but there are a few minor and no clarifications. Step-by-step differentiation, right hand side, and it's going in a pretty good way. Factor out dy over dx, solve for dy over dx. So final answer is your structure was mostly in notation and formatting. Okay, so 326, 339, 339, 313. Okay, so we are correct. This is the answer. So this is the answer to this derivative problem. And although it might seem so big and obviously large, we can solve it. So maybe we can like go for another question like this that tests our level of understanding now, because like we have already had a practice with this question, so like we can practice a few more questions. So the video is already 2 hours long, but still it doesn't matter because like we are practicing, and practice can go as long as it wants to be taken. So let me go for another question. Another question is, I can differentiate the function, okay, x squared y cubed. Let us differentiate the function x squared y cubed. X squared y cubed plus x cubed y squared. X cubed y squared is equal to a squared. Is it? Alright, so this is the question. So it needs to be differentiated as well. So we need to find dy over dx. So we say differentiating both sides with respect to x, and okay, yeah, whatever we used here, this is called the chain rule, right? Like I can give you an example of chain rule. Okay, we have it. Let me go here. The derivative of if we want to calculate the derivative of let's say anything like f of x times x, and we can write it as the derivative of something else. If we want to calculate the derivative of f of x times x, and what we can do, okay, let me give it another example. Okay, let me do it at last. Okay, I'll think of a good example. So differentiating both sides with respect to x, what do we get? Well, we get d over dx of this being equal to d over dx of a squared. And then we say, or now simply use the product rule for both of these after using the sum rule. Okay, let me write this one step by step, and the other one I'll skip the steps, right? That'd be quicker. And so this is going to be the derivative of x squared y cubed plus d over dx of x cubed y squared, which is equal to 0 because a is a constant, or use the product rule. The derivative, okay, y cubed times derivative of this plus derivative of y cubed times x squared, and then again use the product rule, which is going to have this. What happened? Okay, plus something like this, which is equal to 0. And now we can say or x y cubed times derivative of 2x, right? So the derivative of 2x is, x squared is 2x plus and x squared times the derivative of, I'm writing the question this time only, I'm not question, but I'm copying the steps this time only, plus y squared dot 3x squared, right, plus x cubed times the derivative of 0 dx of y squared is equal to 0. So simply you do it like this. And then we already have two of the terms differentiated, so which is these terms, and the constant can be sent to the front. Is that 2? Yeah. Plus now we need to differentiate this. I'm writing the things just for the sake of clarity for this time, and I'm feeling absolutely bored to write this, but still I'm writing for you guys. And I say or, let's copy this thing as it is, and I say plus, copy this thing, but this has to have some modifications. This is dy times dy over dx using the chain rule, plus c dy times fraction dy over dx, and this is basically equal to 0, and we say or, and copy this entire step. After you copy the entire step, what you do is basically add the thing, and what you need to add is this thing. Let's just add this x squared, and now the derivative of y cubed is 3y squared with respect to y, of course, times dy over dx, right? I hope you see that. It is just that, and plus x cubed and 2y, and again dy over dx, and that's also equal to 0. And since this is equal to 0, what we can do is we can say let's keep this thing on one side, and put a minus sign after this. This is equal to like something like this, and then you take in, you factor out dy over dx, and then what you have is the product of 3x squared y squared plus 2x cubed y, which is again equal to this thing right here, and dy over dx is equal to this divided by this. So this is the derivative of the function. So if you want to check the thing, we copy it out, give it to ChatGPT, and say check if it's correct. You're clearly getting the hang of whatever it is. I just want it to be checked out. So it's using the product rule and doing a bunch of stuff that I don't want to see because it's absolutely hot here. It's like 40 degrees probably. I think it's more than, not more than 40, but it is high. Your steps are correct, final result is accurate. So notation clarity is like, I'm using this tool, so, but still I think it looks pretty clear, and it looks very clear. I think it's good. So this is the solution to the question, which is absolutely awesome, and yeah. You can leave this as it is, or you can take in like xy common from here and x square y common from here, but that would make much difference, so you can leave it as it is here. And this is what we have done till now. In the past 2 hours. So this is a lot of things that I've written down for you guys. I hope you guys are liking the video, and this is like going pretty good. So we have also looked at graphs, and we have looked at different types of rules of derivatives. And the recording is going on. Okay, it's going on. And trigonometric functions and all. So yeah, I was downloading a file. That's downloaded. What the hell? It's not yet downloaded. Where is it located? Okay, so let's do another question. Let's see which question we can do. Okay, this looks like a pretty good question. Like now we need to use our sixth sense, if that's what can be said. And I haven't done these sorts of questions, like the ones that are coming, so that would be fun. And which question was this? Like question number 5? Okay, let's give another question now. And let me save it for now. Okay, another question is, it says if y equals to the square root of x plus the square root of x, so that what happened? dy over dx equals 1 over 2y times 1 plus 1 over 2 times square root of x. So this is what we have to prove, right? This is another question, and if you guys are liking the video, then you can like the video from the video section in YouTube, and also comment on the video what you liked and what you disliked and what I can improve in the next videos. And also, like, my next video on VMware installing macOS is coming pretty soon, maybe just today or tomorrow. But yeah, and if you guys want me to upload videos on trigonometry, like I'll go from very starting of trigonometry like I did in calculus, although I didn't go with limits because that would take a lot of time, and I presume that most of you already know about limits. So yeah, and we need to prove this now, right? So we have y equal to this, and we need to show that this is equal to that. Right now, how do we do it? Here we have, what do we have? Well, we have this. So we need to show dy over dx. So how do we get dy over dx? We differentiate both sides with respect to x. So differentiating both the sides with respect to x, we get frac dy over dx. That's d of the square root of x plus the square root of x over dx. Now we need to differentiate the function, right? Now this looks a bit tricky, and let's see, we'll figure out a way together. So if we look out carefully, this can also be written as d over dx of this thing raised to the power 1/2, right? The square root is 1/2. So now if I use the chain rule, I get d over dx, no, not d over dx, but I need to, what happened? I need to differentiate this function, so I need to have d over d of this. It's going to be product, of course. Now, this times out of the fraction d over dx. So now we can use the power rule, so that's 1/2 times this thing raised to the power negative 1/2, because 1/2 minus 1 is minus 1/2, and all these are going to be inside of a bracket. Right, like that. So dot. Now we can differentiate the other function as well, d over dx of that. So that's 1 plus the derivative of x to the power 1/2. So 1/2 times x raised to the power 1/2 minus 1, that's minus 1/2, right? Because that's 1/2 minus 1, which means that's minus 1/2. And we have come to this part, and now what we do is we can, like, we have to sew, what did we have to sew? dy over dx is 2, okay. Now we need to sew that dy over dx, so we have here dy over dx, right? Same here. Where we have the dy over dx thing. And now we need to sew the right hand side in terms of y. So we need to think of a way with which we can do that. So now look at it. We say or dy over dx is equal to, in big brackets, 1/2 times 1/2, and in the denominator it's going to be the square root of this. I hope you get that. Because, like, it's a negative 1/2, so it goes to the denominator, and 1/2 is the square root. And now again times 1 plus 1/2 1/2 and 1/2 in the denominator root x, because, like, that's x to the power minus 1/2. And then we can say, therefore, dy over dx is equal to 1/2, and this thing right here, what is it? It's y. Right? 1/2y times, we're trying to get in the same form, plus this. What happened? Okay. So this is exactly what we needed, and also exactly what we got. So we have proved that. Hence, it is shown that dy over dx is equal to 1/2 of 1 plus 1 over 2 root x. And we are just doing simple questions till now. We haven't gotten into the questions that involve doing the products and other stuff. So those would be super fun as well. And the video is still going on. Pretty good to see that. Let's see how it looks when zoomed out. Like the alignment of the text doesn't look that great. But still, it looks pretty good. And we haven't started like integration yet. And we are still going in differentiation right now. And let me see if there is any other question that we can do. Okay, we have like one more type of question. Find dy over dx if y equals to 2t squared minus 3t plus 2. Now how do we get the dy over dx, right? So for this, we have to use some other ideas. Like, you have y equal to 2t squared minus 3t plus 2. So copy this. We have y equals to 2t squared minus 3t plus 2. And now, if we want to differentiate the function, we will be needing to differentiate the function with respect to what? Well, we will need to differentiate the function with respect to t. So sides with to t, because t is the variable here. So dy over dt is equal to dy over dt of this entire thing here. And I hope my audio is still being recorded, and yeah, it's being recorded, which is a pretty good thing to have. So dy over dt, and now this is simply going to be 4t minus 3, which is going to be equal to dy over dt, right? And now we cannot stop at this point, right? Because the question says, and t is equal to 2x squared. T is equal to 2x squared. So we say, we copy this first, and we call this equation 1. So we also have this. So what do we do now? Well, what do you think do we do? Okay, I want you to think once. I want you guys to think what we can do in order to get the value. Well, we can do something like differentiating both sides with respect to x once. So that's x. Okay, yeah, we can do it with x, because like we would get, and I think we can do that. Let's see. So dt over dx equals to 4x, right? dt over dx is like equal to 4x. And now let's call call this another equation. Equation 2. And we should now be looking at how we can get dy over dx. Right? dy over dt. So dx over dt. What if we differentiate this with respect to t? Let's see. With respect to t, if we differentiate that, then for that we need to have x square equal to t over 2, right? And that means x would be cut out the square root of t over 2. And now we will have to differentiate it. So dx over dt would be equal to the frac d over dt of this. We would be differentiating this with respect to that. So it would be equal to 1 over root 2, right, times d over dt of root t, that's t to the 1 over 2's power, 1 over 2, so that's just a second, equal to 1 over square root of 2. Now that's 1 okay, 1 over 2, so that's 2 square root of 2. Minus 1 t to the power minus 1 over 2, that's going to be root t. So that's square root of t times 2t, square root of 2t. Right? That would be frac dx over dt. That would be 1 over 2 root 2, and then that would be minus 1 over 2. 1 over 2 square root of 2, so square root of 4 times the square root of 4 is equal to 4 times 16 is equal to 4, so yeah. And now that would be called equation 2. And now I do something like dividing equation I by equation double I. What do we get when we divide this equation by this equation? Let's see what we get, right? So dy over dt, frac dy over dt divided by dx over dt is equal to frac 4t minus 3 divided by, let's do like for clear visualization, divided by 1 divided by the frac of, okay, not even frac, copy this. We say or, and if we do this way, dt's get cancelled out and we get dy over dx, which is equal to 8, where is 8, t square root of 2t. So that would be 8t times the square root of 2t minus 6 times the square root of 2t, right? And that would all be divided by what? Nothing. That would be divided by 1. Now we have this as dy over dt, dx, and so or frac dy over dx equals to square root of 2t as a common factor, and we have 8t minus 6, or frac dy over dx is equal to square root of what is t equal to? 2x squared, right? And then 2 times 2x squared is equal to 4x squared. 4x squared times 8 times 2x squared is equal to 16x squared minus 6. And so dy over dx is equal to 2x times 16x squared minus 6. And then finally, therefore, dy over dx is equal to 32x cubed minus 12x. So this should be what dy over dx is. In order to check, we can give it to ChatGPT, which will check the question. So what is our answer? And okay, let me do a thing. I can like take a common factor of 4. So 4 times 8 is 32. 4 times 3 is 12. So I've taken these as a common factor, and now this is my final answer, although I could have left it in the same form. So let's see. Where is the other question? Another question. Where is this question? We also have find dy. Okay, here it is. Let's say check if this is correct. So ChatGPT will, you're very close again. This is the same rule and approach most carefully. There are few small notation. Okay, we don't need notations because we're using some apps. When we do by hands, that would be just fabulous, you know. So for x, 8x. Oh yeah, I could do that, but I don't want to. So you mistakenly used the x instead of and inverted it. Complexity by okay, no problem. We did it correctly, right? So this is correct, and what else can we do now? I think we can do like a few more questions. It's just 2 hours 48 minutes. Okay. So now let's know what the second derivative of a function is. Alright? So let me first give you a bit of theory about what the second derivative is. So second derivative. So the orders of derivative. So we have different orders of the derivative, which can be the first order is dy over dx, which is f prime at x. The second order is dy over, I think, ddx. I think, right? That's f prime x, but double prime this time. Open guest profile. I can be quicker by 4 plus 2 notations. I don't know if this is spelling correct. Just notations. No unnecessary writings. So yeah. Okay, so it's d squared over dx squared, sorry. Okay, so d squared over dx squared, third derivative is d cubed over dx cubed. So that's how we do it. The second order derivative is like done in this way. Now, in order to calculate the second order derivative, we'll have to first calculate the first order derivative and differentiate the obtained value. For example, f prime of x is equal to prime of f. So this is the second order derivative. Right? Now, so calculating the first derivative. Okay, now let's go for a question. Calculate the second order derivative of y equals to x squared minus 2x plus 5. So first order derivative is like dy. Let's say x, so flat dy over dx is equal to, okay, let me directly write it 2x plus x minus 2. Now, differentiating again, the square y over dx squared. This is just the notation for second order derivative. That's 2, right? So the second order derivative is 2. So let's see if I'm correct. Okay, I'm correct. Now I wanted to check something, but that wouldn't work. So I'm leaving. Yeah. So the D's, I mean the upper D and the lower X are going to have the power equal to the order of derivative if calculating any order of derivative, whatever. My tongue is slipping now. The derivative. So yeah, in this way, I calculate the second order derivative of y equals this. We have done that. Now I think we can do one more type of derivative, and then we can move on to like the derivatives of trigonometric functions and different sort of things. And that would be so fun to do and so cool as well. For that, let me do a thing. Okay, let's not do it now. Now, what shall we differentiate? Now it's starting to like kind of rain over here, so I'm unplugging my laptop. Okay, so how many charges does it have? Okay, 79%, pretty fine. So the second order derivative, I hope OBS does not go off. Okay, it's not. So for the second order derivative, what do? Not second, but okay, we have one more question. So it says differentiate x squared plus 2x minus 1 with respect to x plus 1. So we need to differentiate x squared plus 2x minus 1 with respect to x plus 1. So we say here the function to be differentiated is. Yes. So now we are going to be differentiating it with respect to x plus 1. Right? So that's going to be frac d over d of this one. This. Now we need to have a way. So what do? We say or is equal to d over dx, and d of x plus 1. If we take an x as common factor, then x plus. Let's do x squared. This is my way, whatever has come to my mind. Plus 2x minus x plus x minus 1. So I'm just rearranging the things here. So that's just x squared plus x. Right? Plus x minus 1. And now what we do is say or d over d of x plus 1. And if we take an x as a common factor, x plus 1, then we have this, and then minus 1 if I take in as a common factor x plus 1, then x minus 1. So it's also d over dx of this, right? So we are differentiating this with respect to this, and I think I want to do something else. Like, this is getting so long, I don't want to do that. So what I do is, well, look at the trick. This is what we have, right? So So we will divide. Or we can like multiply, but dividing and multiplying is the same thing. Okay, let's divide. So if I divide both the things with x plus 1, right, x plus 1, and this is going to be something like divided by x plus 1, and this x plus 1 is going to be cancelled out. But I don't think this works in this way. Let's get it to ChatGPT. It's also there, right? Hey, how do we differentiate distances? We use the chain rule. Oh yeah, how could I forget that, right? So I already told you guys, we know how to do it, but that's not in our mind within that very moment. But now, since I've known how to do this, I should be able to remember this for the entirety of my life. So that's the purpose of learning. So that's what I think is the purpose of learning, because like if we don't remember it for the lifelong period, then that's just no use. And learning means like taking knowledge, not taking education. So if you take education, then that's just temporary, but knowledge is eternal. So you will have knowledge, and you should be able to differentiate what knowledge is from what education is. For example, learning math, it's absolutely pure knowledge. Learning physics, it's also knowledge. Learning different kinds of structures, different religions, different philosophies, it's knowledge. But if you like just learn formulas, and if you like learn programming languages, then that's education. So education is what makes money sometimes, specifically for programming languages, because programming language is not knowledge. Coding is not knowledge, because that's just within the computer. If there was no computer, there would have been no coding. So that's limited. But if you do mathematics, it's knowledge, and it's used everywhere, like in coding, like in real world. And you should be able to take knowledge and education all together at the same point, in an equilibrium. But if you just go on taking education and stop gaining knowledge, that's going to be a bit bad. But if you go on prioritizing education over knowledge, still the same thing, that's going to be bad. But if you go and keep knowledge on your top priority after like the other greater priorities, except for education, then that's going to be better, because knowledge is what creates education. Because like whatever today we are studying at English or math or science in school or colleges, see, that is education. We are getting that as education. Let's take mathematics, or let's take physics as an example. So we are learning physics, and that's education, because people say F equals ma. They don't know why it's F equal to ma. Why is it not m squared a? Why is it not 2 times ma? Why is it not m cubed a? Why is it not ma raised to the 5th power? Why is it just ma? And why is the force of gravity just proportional to the product of the masses, and why not like the square of the product of the masses? And why is it inversely proportional to the square of the distance? Why not the cube of the distance? Like, people don't know these things, and that means they're taking education. But Newton, who developed this, had developed it, and what he gained was knowledge. So knowledge is being transmitted into education nowadays, and I don't think that is great. That is just bad, because people would lose their creativity. And programming, although it is education, it within has a lot of knowledge, because it just makes you think critically and deeply about different topics and how to create logics, and that's what we know as education sometimes as well. So it's important to gain knowledge more than education, because if you're a scientist and you're working on a theory and that's created, and you had a knowledge, you had all the required knowledge to find out the theory and create it, and when you formulate that theory after 100 years, the students will be learning that in the course of their education and not know how it exactly came. You do not have the intuition for everything like that. So it's absolutely important to prioritize knowledge over education, and even if it means you're a bit slower than other people, but you have the solid understanding of the things, then you're greater than them. So yeah, that's what I wanted to say. Now let's continue. So differentiating with respect to x plus 1, we are differentiating the function x squared plus 2x minus 1 with respect to x plus 1. So what if I do, okay, let me try this. D over dx, right? And then d over dx, dx over d of 2x minus 1. So this is at least gotten simplified, right? It has gotten a bit simple. Let's see what happens next. For now, it's going to be 2x plus 2 times 2x plus 2 times the derivative of x with respect to 2x minus 1. So dx with respect to d 2x minus 1. So now we have 2x minus 1, and we don't have any 2x minus 1 over here. So how do I differentiate this now? Let's see. How do we differentiate this? We will proceed using reciprocal rule. Let's see. If we reciprocal that, then we get 2. So, oh wow, this is a pretty cool logic, right? Using the reciprocal rule, that's equal to 2x plus 2. Now, I don't guarantee that I will remember this for the entirety of my life if I don't use it a few more times from now, but if I do, then I should, because that should be embedded with the branch of knowledge in my brain, in my mind, in my thoughts. So, I don't know where the formulas came from, to be more honest with you guys. Where did they came from? Where did they come from? I know a few formulas, how they emerged, but I don't know how all of these emerged. And so if you have the curiosity to learn, then what you do is you find new things. Because if you don't have the curiosity to go for rediscovering the things how people did, then there's no way you're going to be discovering a new thing unless you have a pure good luck. So, frac d of 2x minus 1 and dx. No, that cannot be written as this. Right? Is the reciprocal of this. So derivative of this is 2, which means it's reciprocal, i.e. this thing's derivative must be reciprocal of 2, which is 1 and 2. That'll be 2x plus 2 times frac 1 over 2. So if I divide all of these, then it's okay. right? So that's the derivative of the function 2x squared minus 2x plus 5 with respect to what? Leave that. That's the answer. Wait a second. Okay, I'm back. I had gone to drink some water because it's important to hydrate. And my room is totally dark right now. It's been like 3 hours. So let me turn on the lights first. So I have turned the lights on. So that's pretty good. And it's about to rain, which is my favorite time right now. So I think if it's if it's getting cooler, then that would be better because I could like go a bit more. And let's see what the differentiation gives as the result for that. I think I have already given the question. Okay. Final answer 2x plus 2, but I got x plus 1. Isn't it x plus 1? Okay, but what did I miss here? What did I miss here? I mean, I used the chain rule here. So 2x plus 2 times, that's plus 2. So I wanted to check this. So let's see. It's clear that you're thinking carefully through the steps. Let's walk you through your work and let's see. This is correct. Okay, this is incorrect. You're differentiating with respect to x plus 1, but you introduced 2x minus 1, which is, oh yeah, I was differentiating with respect to x plus 1, right? Not 2x minus 1. So, then dx, yeah, plus 1. I don't know what made me write that, but you know, x plus 1, x plus 1, x plus 1. 1, 1, 2x plus 2. So this is the final answer that we obtain. So let's differentiate one more function of similar type, and then we can move on to trigonometric functions, which would be more interesting, and we can use better chain rules in there. So differentiate, which can we differentiate? Okay, let's differentiate another function next. Differentiate the square root of 5x minus 4 with respect to the square root of 3x plus 2. So we will differentiate the square root of 5x minus 4 with respect to 3x plus 2. That would be so great. So differentiating root 5x minus 4 with respect to 3x plus 2. So that's going to be giving me square root, frac d of square root of 5x minus 4 divided by dx times frac dx over d square root of 3x plus 2. And now I hope you're getting what I'm doing here. Alright, I hope you're getting what I'm doing here. That would be equal to what comes next. So actually we cannot differentiate in that way. That should be differentiated with respect to 5x minus 4. 5x minus 4, because like 5x minus 4 is the coefficient here, and that means it has a power of 1 over 2, right? That is the power of 1 over 2, 1, so subtract 1 over 2, 5x minus 4 raised to the power 1 over 2 minus 1, that's minus 1 over 2, minus 1 over 2 times, now we have ended up in another situation, but this situation is a bit easier compared to the other situation, because like that was a bit, you know, problematic, but now we can differentiate the function. So 3x plus 2, should I differentiate 3x plus, no, I don't want to, but I can do a thing. Like, I need to differentiate this part of the equation, and 5x minus 4, right? Let's see. So that gets differentiated really easily, but now I think I can use the reciprocal rule. Using rule is frac d per 3x plus 2 divided by d 5x minus 4 d5x minus 4, right? And now what we can do is Like if we do in this way, that would create another problem. That would be, but no, that wouldn't, right? We can't do it. So that would be differentiating this now. Now in a fraction, and in a fraction with respect to 3x plus 2, x plus 2 times the 3x plus 2 the 5x minus 4 has gotten a lot easier. And now this becomes 1 over 2 times, so that's minus 1 over 2, so that's still root under x plus 2 dot. Now we will use the chain rule to differentiate that. So dx plus 2, and that would be over dx dot dx over d 5x minus 4. Now, so I think we'll have to use the reciprocal rule 2 times. This would be equal to 3 over 2 square root of 3x plus 2, and now times this. Reciprocal of this is the 5 minus 4 over dx, and its derivative is like 5, so the 5 to the reciprocal of 5. This would be equal to 1 over 5. So that's 1 over 10. Now this is the derivative of is this derivative of must be 10 times the square root of 3x plus 2 divided by 3, which is its reciprocal. So we continue from there. So equals to and from here, where did we start using the reciprocal rule? yeah, from here, I can copy this entire part and keep it just like that. This is 1 over 2 times this. I think, like, you know, it's absolutely long right now. It's back 1 over 6. Not 1 over 6, but 10 over 6. 10 square root of 3x plus 2 over 6 times the square root of 5x minus 4. So that's going to be 5 over 3. 5 times the 3x plus 2 divided by 3 times the square root of 5x minus 4. So this is the derivative, and this is like absolutely big. Oh wait, this is not dx, so this. Let me copy and paste the question and ask ChatGPT if I'm correct. It can be wrong because like it was big and the notation in the app wasn't that so clear. Like it's looking so messy right here. Right? It looks so messy, but still I tried. See, why does it take like some time to load the page? Probably due to a lot of writing. Here. Not verifiable as written. You need to specify what y equals fx is. What does it mean? Where is it? I haven't mentioned y equals fx anywhere. What? That's not dy. Over that. Oh, I see. That's not y. So that's... Our expression is this. There was 3x, root 3x plus 5 instead of 2. Oh yeah, it is 2. Yeah. So this is also correct, and I think there is obviously a shorter way to do this question than how I did, because like it's a bit lengthy, it's a bit long. almost 2 pages in a copy. That's a bit too long, but still, it is fun to do. So let's see what it did. So let's define u equals this and d over this, du over dv by the chain rule. D over dv is equal to d u over dx times dx over dv. Compute each derivative. I think it also used the same thing. Great question. Yes, I partially used the combination. Compute. Okay, then I think it did use the chain rule. So it's like also pretty good. And this was a pretty good question. Right? And now we can look for other questions as well. Like differentiating other functions and all. And like we have completed a lot of questions today. We must agree on that. Let's see how many questions we have done. So these are just some functions, and these are just some concepts. These are just some rules and formulas. This is the first question. Second question. Wait, I don't know. Okay, it's up to fifth question here. Alright, up to fifth. And then this quest is a sixth question. And seventh question here. Eighth question. Ninth question. And 10th question, 11th question. Okay, we have done 11 questions in the 3-hour video, which were pretty good, and like they ranged from very easy to a bit harder, like with the increasing order of difficulty, whatever we pronounce it as. And okay, it's already saved. So I can keep this much for the video, but what should I do? Okay, let's do this much for the video, and we can continue the trigonometric part in the other video. Like, it's already 3.5 hours long, so we will continue the video. So we will continue the video in the other part, and we have completed like the normal differentiation, right? And I had told you that I would teach you derivatives in the starting of the video, and I did that. I've taught you a lot of things today, and I have learned myself a lot of things as well, and this is like a good foundation for starting to learn derivatives. And if you like the video, all I want you to do is press the like button down there in the section where you can do all this stuff, and also press the subscribe button, comment, because you've watched a lot and you've watched like 3 hours straight, so that was a lot of effort. So just to prove that effort and just to acknowledge that the video was good or bad, I want you to comment it and just tell me how the video was. And if you can, then share the video, because like there are many people who want to be learning these things, and this also makes me make more videos on YouTube. And I'm going to be uploading one more video maybe today or tomorrow on how to install Mac OS on a virtual machine in Windows device, so that would be a great video as well. So yeah, and on this channel, like, I've started also uploading sometimes math videos, so you know, when I get the mood, but this is still primarily going to be the tech channel, so we will be uploading another videos tomorrow or somewhere. So yeah, this is it for the video, and I hope to see you guys in the next video. So till then, this is practice, and if you don't practice, there's no problem, because you just have to keep this in mind. So that's the main thing. So bye.